Okay, number 41, it says matrices. So adding and subtracting, these kind of operations are really kind of basic when it comes to matrices, okay? So if there's a 2 in front of the variable, okay, so A, it's obviously talking about this matrix right there, okay? So 2 times A means that we're going to be multiplying every single thing by 2 on the inside, okay? So watch this. The dimensions are going to stay the same. So 2 times 2, that's going to be 4. 3 times 2, that's going to be 6. Negative 1 times 2, that's negative 2. 5 times 2 is 10. That's going to be 0. That's going to be 8. Okay, so this is A times 2, okay? Now I have to add that to B. So watch, I'm not going to put B next to it. I'm just going to put my answer because most of the time you can just kind of look at this stuff. Okay, so I'm going to take this thing and I'm going to add it with that one right there, okay? So we add each corresponding, this is not like multiplication where you have to go row by column, okay? You just have to add each of the terms. So 4 plus 2, that's going to be 6. 6 minus 3 is 3. Negative 2 plus 4, that's going to be 2. And then 10 plus 1 will be 11. 0 plus 5 is 5. 8 and 7, that'll be 15. Okay, so there's your answer right there in blue. Okay, so do the same thing for B, do the same thing for C. Check your answers with the answer document. The only thing that I'd watch out for is this. Let's say if you had this scenario where it was like 2A and then you had minus 3B. Okay, if you guys had something like this, do you multiply the B times a negative 3 or by just the 3? Well, it depends. I mean, what are you going to do with this? Like, I would say just do the 3 to the B and then subtract them afterwards, okay? Because sometimes if you pull the negative 3 in and then you try subtracting, then you just did the negative twice. So watch out for that and don't do that. Okay, but 41, everything else is pretty much self-explanatory. Just remember, like B and C, those ones can't add or subtract because the dimensions are not the same, okay? It goes by rows, by columns. Okay, 42. It says give the dimensions of each. Okay, so this one has 1 row by 1, 2, 3, 4 columns. That's all you got to do. Rows by columns. So this one is a 2 by 3. You guys can try that one. All right, next, your favorite. We have to solve these systems. Okay, in order to solve the system, hey, I already did a 3-variable system. Okay, that's on one of the other problems. I think like question number 9 or something. So go look at that one. Try this one on your own. I will do this 2-variable one though. So in order for them to cancel, this one up top needs to be a negative 6. So how do I make this a negative 6? We got to multiply everything here by negative 2. So I'm going to multiply this by negative 2 and come up with a new equation down here. So this times this is negative 6. This times this is going to be a positive 4y. And then this times this is a negative 8. So watch. 6's cancel. The 4's cancel. So I'm left with 0 right here. And then right here, this. That's going to also give me 0. Now, here's a weird situation where the variables cancel out. And what the heck? Like, here I've got a 0 on this side and a 0 equal on this side. Now look at this statement, this sentence. It says 0 equals 0. Now is that true? Yeah, it's true. So if it's true, that means that it's not a no solution. It's got to be the other thing. Do you remember what the other thing is? Good. That's when it's the infinitely many. Okay? So let's just say that you had a scenario where it was like 3 equals 0 or something like that. Like obviously that's not true. So this would be no solution. Okay, so that will happen. Okay, part B. Remember, you're trying to make a 2-variable system from a 3-variable system. So utilize that. Let's keep going and see if we can hit up number 50. Okay, 50. All right, we have to. Okay, so basically, to tell whether the system is consistent or inconsistent, it's asking, does it have a solution or does it have no solution? Okay? And then how many solutions are there? 1, none, or infinitely many? Okay, so that's basically what you have to do. So you'd have to solve it and see what you get. That's how you do number 44. Okay? Next, number 45. These are called complex numbers. Complex numbers, like that's just whenever you have a negative underneath the radical. So here, if you guys recall, I'll do it down here. If you have a negative 1 underneath a radical, that's equivalent to I. Okay? So if I have a negative, that means right now I could pull out an I, and I'd have the square root of 12. Okay? So the I is on the outside, and the 7 is still right here. So then we'd have to just simplify this. So what's the square root of 12? Well, 12 is the same as 4 times 3. The square root of 4 is 2. So this is 2 radical 3. So how I'd simplify this one is I'd leave the 7 there. The 7 can't do anything. And then I have plus the 2 came out, so did the I, and then the radical 3 stays on that side right there. Okay? So let's remember the sequence. So I obviously equals I. What is I squared? Negative 1. Okay, what's I to the third power? Negative I. What's I to the fourth? 1. Okay? Remember, it's I1, negatives in the middle. Guys remember that? So that's going to be important to do all these things. Okay, do you guys want to see one where you're multiplying? Or does it not matter? Maybe we could do part D. Okay? So this one, the square root of negative 4 is going to be 2i. So I have 3 times 2i. That'll just be 6i. Okay? And over here, the square root of 36 is 6, but then the negative, that's going to be 6 times 6i. That'll be 36. Now since both of these have an I, we can combine those. So that'll be 42i. Alright? So everything else is, you just FOIL. Okay? Just FOIL, and if you get an I squared, just remember that that's negative 1. Okay?